Amazing. Anyway, Ricky Vetter.
Yeah, cool. Awesome. Thank you guys. Really fantastic to be here. Just want to thank the organizers for putting this on and for all of you for attending. It's been a super awesome conference so far, and I'm sure the rest of the day is going to be great as well. Just a little bit about me. My name is Ricky Vetter. I work at Facebook on the Messenger web team as a front-end engineer. I do a lot of product work on the team, so working on building up new features for Messenger.com and for messaging on Facebook.com. But I also spend quite a bit of time working on ReasonReact and working on some other open source libraries and chatting with a lot of you folks in the community. So definitely always happy to chat if anyone has anything that they want to talk about. You can reach me at Ricky Vetter, Twitter, Discord, basically anywhere. So yeah, let's get started. So today we're going to talk about how this is really kind of a deep dive and expansion on a lot of the stuff that Jordan was talking about in his keynote, about how kind of Reason and React fit really well together. First off, we're going to go through sort of the philosophies of these two sort of, well, one language and one framework and how they share a lot of similarities there. Then we're going to talk about how React can be made a little bit better with Reason today, and then we'll talk about how, what the future might look like for the two. Just as a disclaimer throughout this talk, I'm only really using examples from the function API in React, using hooks as opposed to the class and lifecycle API. If you're not familiar with this, I highly recommend you look up like the open source documentation for it. It's pretty exciting and a lot of fun. I'll go through like a quick run through of how that works in a bit, but just so you know. There's tons of sort of content that already exists about the sort of philosophies of these different technologies, and not even just Reason, but like also BuckleScript and OCaml and how these all fit together. And so this is sort of a spattering of like a little bit of all of these things that I'm pulling in, but super interesting to read the histories between these as well. So highly recommend like this as sort of reading if you're just interested in why these technologies work the way that they do today. So the first like main sort of philosophical thing that I want to talk about is this preferring of immutable values. React generally encourages immutable values throughout its API as a sort of shortcut for being able to guarantee performance and behavior in certain situations. So the most obvious case when you're using the hooks API is with the dependencies sort of array that you have at the end of quite a few of your hooks actually. That sort of tell you when that hook needs to be re-executed. So if any of these change referentially, then React is going to re-execute that sort of operation for you. And this is true for use callback, use effect, and a couple others. And the main point for this is to be able to sort of give you some control over when these things execute, because the sort of functional components don't give you that by default, right? The whole thing is going to get executed, so you do that. You also have React.memo, which sort of is happening at the entire component level, so it's expecting that all of your props are immutable, so that it can use referential equality to sort of shortcut the rendering of an entire tree of components if everything matches, basically. So basically throughout the top level API for React, it's kind of expecting that you're going to be working with immutable values as much as possible. Quite conveniently, Reason as a language is pretty immutable by default. Almost all of the common data structures that you're going to be using are immutable unless you explicitly opt into something. And you sort of have these very special data types that allow you to do mutable things. Funnily enough, the primary way that you do mutation in Reason is with refs. And React refs, if you're using like a use ref hook or something like that, are directly modeled and are essentially the exact same data structure as a Reason ref. Like they work in the exact same way. And so there's like Reason and OCaml are used as sort of prior art for the defining of how use ref is going to work. So they are literally the exact same thing. In addition to that, both React and Reason are very intentionally adding escape hatches to be able to sort of leave the paradigm that they really want you to stay in order to be able to ship products that you need to ship. I think that the React team is super understanding of the fact that before building like beautiful pieces of code or really interesting sort of conceptual things, that at the end of the day, like most of us want to just be able to give the people that we're serving like really incredible performant products. And sometimes it's too hard to follow that model exactly all the time in order to be able to ship on the timeline that you need, right? And so refs in particular are often used as sort of an escape hatch to be able to model mutation across many different renders. Usually if you're using a ref in a React component, there's probably a way to do that better, but it might take a lot longer and it might be a little bit more obtuse in how it's ended up, in how you end up writing that code. They also offer sort of imperative handles so that you can be able to do some more object-oriented code and be able to work with components in a way that isn't sort of as declarative as the sort of default React model might be. They also sort of provide an ultimate escape hatch, I guess, to sort of leave the React paradigm entirely and basically just use whatever method you want to be able to set HTML in certain cases. Again, they don't really recommend that you do this, but they offer this so that you can ship products quickly. Similarly, Reason offers escape hatches, so you've seen these in a lot of code examples today. If you want mutability in your code, you can get it quite easily. So you can use refs and be able to mutate these refs. And similarly, you can have like mutable fields on your records and then be able to mutate these directly instead of creating an entirely new record. We also have sort of a set of ultimate escape hatches in Reason where you can sort of promise to Reason and to the type system that what you're doing is safe, and you can circumvent sort of how it's doing its own type checking. So in a lot of ways, this is similar to the dangerously set inner HTML, that this is never really recommended, but in certain situations, it might make sense to be able to ship something quickly to do this. And so in this example, we've created a function here that's using this sort of very special and obtuse language to prevent you from writing it accidentally, to be able to say something that is a string and promise the Reason type system that it is actually an integer. And then you can then promise it back that it's a string. Specifically when targeting JavaScript, there's another potentially even more ultimate escape hatch for being able to just write arbitrary JavaScript. This comes into something that I'm talking about a little bit later, which is sort of being able to iteratively introduce both React and Reason into existing code bases. Sometimes you have a really complex untyped JavaScript function that you need to be able to execute for any number of reasons. It doesn't really matter. It's not Reason's business why you want to run this function. And you can't convert it to Reason right now. And BS_raw, which is what the %raw is here, allows you to just sort of insert arbitrary JavaScript code into your Reason code, and it works just fine, which is pretty sweet. So yeah, another sort of core philosophy that you'll see with both of these technologies is a real focus on interoperability with other technologies and gradual adoption. With React in particular, you'll see that there are hooks for both inserting, it uses the DOM basically as its sort of platform, right? And it says, well, we can take ownership of a specific DOM node, and then we can also give up ownership of our child nodes. And so it explicitly doesn't write over child nodes blindly if like you have like a div with a specific ID that you're rendering, so that something else can target that and insert things into that area. And it can also sort of claim ownership of just a very specific place. So it's able to sort of iteratively take over pieces of your app, and if you want to experiment, try things out, do that kind of thing. On the Reason side, there's two tools that make this really, really incredible for JavaScript targeting in particular, and that's BuckleScript and GenType. BuckleScript is really nice because it gives you per file compilation, and it integrates with most of the build systems that you guys are using with JavaScript today. And it also allows you to get really, really idiomatic JavaScript output. So you can write bindings and work with really esoteric sorts of JavaScript that's using obscure patterns and something that might not be really easy to target from Reason, which uses a sort of a different set of paradigms and things that it's interested in. And then GenType in particular allows you to, if you have an existing TypeScript or flow code base, it allows you to iteratively add Reason code to your code base without losing any type coverage at that gap, right? Because if you're manually describing what happens in a TypeScript file, and you didn't have some sort of validation that what you were describing and what TypeScript thinks is happening is the same, then there would be a gap in the type coverage at that line, which would make your code overall less safe. And GenType completely nullifies this issue and makes it so that we can sort of iteratively add new code that way. So now I'm going to talk about a couple ways in which Reason directly makes React better today. But I just wanted to run through exactly what ReasonReact is and like what writing React in Reason looks like, because I'm not sure how many people have actually written it before. I guess, could I just see like a show of hands how many people have written ReasonReact before? Okay, cool. So a lot of you, but I'll breeze through it for the people who haven't, just so that we have this context. So this is what a React component looks like in JavaScript. I copied this over blindly, so I might have made a mistake. Excuse me if I did. But basically, what we have here is a function that takes in sort of an object of a bunch of different properties, and basically can return some sort of, HTML-looking results, which is actually just sort of a composition of other elements, of other components, and can sort of be able to do that. On the second line here, you'll see that we're also using a hook. In particular, this one is useState, which actually allows us to keep state across different renders. So we can run this function multiple times, and the internals of React can keep track of that value for us and allow you to update it over time, and the next time it gets called, it'll be a new value. So if we click on this button, count will actually increment, and this function will get called again with a new value for count, right? So in React, the way that you would write it looks a lot the same. The main differences here are going to be that our function is using slightly different syntax for its arguments. In this case, instead of using an object, it's going to be using reason named arguments, which is just sort of a native functionality of the language, which maps really well to how props actually work. And you're also going to have on the first line there an annotation, sort of a decorator you can imagine, that actually changes how this code works so that it actually will be an object on the JavaScript side. And then you'll notice basically everything else is exactly the same except for the sort of React.string wrappers, which a few people have mentioned, and the explicit conversion of the string to an int. And I'll talk a little bit about the React.string in a minute here. This is just if you expanded this decorator. So if you take out the React.component and actually expand that, what it actually does is it creates two values. So React component in Reason is actually two values. It's a make function, which basically just takes an object and operates on it exactly how it would in JavaScript. And then it's also a make props function. And that make props function, in this case, is actually just a buckle script shorthand for like creating an object. So it's essentially the exact same thing as a React component in JavaScript, but it allows you to do some interesting things that I'll talk about later. So it's important to know that it actually splits into two values there, like whatever you call the name of your function, and then that props. So in this case, make and make props. So now into like what the actual advantages are. The first advantage, which I think is pretty obvious at this point, but definitely needs to be talked about, is that Reason is typed and JavaScript isn't. And when you're looking specifically at component boundaries, this is a world of difference. So you can imagine components as sort of building blocks that you can use to construct your app, right? And if you have types, the way that I kind of think of it is like you're putting together Legos. So like there's like very explicit places where you can take a block and say, okay, this is the kind of piece that can fit right here, et cetera, et cetera. When you're using JavaScript or a really untyped language, it's a little bit more like you're on a beach and you're picking up like pieces of driftwood to make this structure. Like there are ways to make really interesting towers, and it's a really artful experience to build something out of pieces of driftwood. But at the end of the day, like it's, you're not going to be able to build a structure that's as tall or as robust and as easy to change as it would be if you were to be using Lego. Not only on component boundaries, which are really the code that you're writing, is it important to have types, but also on the top level APIs of React. So hooks, create element, all of these things are really important to have types just to make sure that you're running an application that is actually going to work at the end of the day and is going to be easy to refactor. I want to touch on TypeScript and Flow here. I think honestly, if there's one thing to take out of this talk is that if you're using React, you should definitely be using it with types. And I think like using any of these 3 technologies is really great and a great step up over using untyped JavaScript. I really have no issue with these. But I think that places where you can really see differences are on the type inference and the refactorability between these 3. And so if I just come back to this example here, one thing that you can really see a clear difference on is like the hooks usage. So in this case, this is a reason example, and we're just saying react.useState, and state is an integer. Both Flow and TypeScript are very flexible with their types. And so you run into an issue where if you actually were to call setCount here with like a string, there wouldn't be any issue here in TypeScript or Flow because it would just expand the type that count could be to be an integer or a string. And you would have to handle that downstream, but in certain situations, so for example, if you were just passing it as like children to an element, you would have no idea that you had actually like expanded that type to become larger than it actually should be. And so you'd run into some issues there. So and it would probably be like in a later commit or something that you would run into issues. Like you wouldn't even notice it at first, which is kind of an interesting case. So in this case, you would actually want to annotate like the value of count in this case, or like the function call of useState to explicitly say that this is like what the state value is going to look like. And there's actually a few cases of this in the hooks API where it's not working the way that you would expect it to work, or the most intuitive way for a type system. And Reason actually gets this right and makes it really easy to sort of use these safely. That said, I think both Flow and TypeScript are looking at sort of changing how this works, and I'm really hoping that they sort of improve this specific case really soon. I think that'd be pretty fantastic. The other thing is like refactorability. I think like anytime you have sort of any uncertainty at all, refactoring can be really tricky. And so lowering that amount of uncertainty is really important, and the type system in Reason allows you to do that really well. And so refactoring at the component level is super easy. And I think it's really a joy of an experience. If you do get an experience to refactor a Reason app before you have to build one, you should try it because it'll really sell you on the idea of building one in Reason. This is kind of related to types, but something that I wanted to talk about sort of separately, which is the first class language tools. So in this case, I'm showing like an algebraic data type. Again, I think we've seen a bunch of examples of these, but it's basically just this switch statement. And we have sort of 2 actions that can happen inside of this component. And we have an exhaustive check, basically. So if we were to leave off toggle, or if we were to add a new type here, we would automatically be warned that we weren't handling all of the cases, and we would be able to handle these. Especially if you have like beefier React components with like a lot of different things that can happen, this exhaustiveness is super awesome. Especially if you're checking in multiple different places. Just the more you have complexity in your app, the more this check is going to be really useful for you. I also want to shout out explicitly for the ReasonReact router. I'm not sure how many people here have used it, but it again uses this idea of pattern matching, although you'll note that there's not an exhaustive check here because we're just looking at a list of strings. We do have a final case that renders like a 404 page here. But the data structure of lists, which is available in Reason, like really lends itself well to sort of modeling these kinds of like typical UI problems, and in this case it's a router. So we can basically imagine that the path is just split on slash. I mean, not imagine it actually is split on path, or on slash. And we're basically just handling all of these routes, and each of these can return a React component, and that's basically like how you would do the routing for your app. And it's like really straightforward and an absolute breeze to write. So highly recommend you look into this, and this is sort of like a language level tool in the switch statement and this list and the pattern matching that you get. Also note that, so if you look at the third line here, we're both checking to make sure that the first and third element of this list are exactly what we expect them to be, and extracting a variable in ID, and we're using that in the handle book edit function. This is something that's quite tricky to do as concisely in most other languages, but especially in JavaScript, which is pretty cool. This one is relatively controversial. I think that a lot of people here have expressed some dismay at it, but the explicit handling of different types of sort of like primitive elements or whatever you want to call them. So in this case, you have to wrap strings that you're going to pass into elements as react.string, or if you have an array, you have to pass it into a react.array. I'm going to show another example, I think, a little bit later that's going to sort of really solidify like why there's value in this. But being able to sort of have a gatekeeper that validates the types for you and makes sure that everything is as it should be can be really useful. And so in this particular case, there's this whole class of React runtime errors that goes away, which is like, oh, React has found an invalid child that looks like whatever, this can't actually be rendered. No longer happens, right? Because we have these. And so I think that there's a lot of value in this, in that you don't ever see these runtime, like you'll never ever see this runtime error in a ReasonReact app because it can't happen. But I'll show another like more interesting example in a couple minutes here. The other thing is the value that the make versus make props can bring. So it's kind of interesting that you have two values that allow you to create a component. So you have this sort of like props, and you can think of it as sort of like a setup for the component where you're actually deciding how you're going to formulate this object, and the actual implementation of the component. And so one thing you can do with it that's kind of interesting is, say you have like a module called button, and it takes a number of different sizes, and then you've actually made the component, right? You could have a submodule that's like large, and basically you don't have to re-implement it or add another component wrapper around it. Like it's literally the exact same component, and you just give it a default size of large, and now you have a large button basically. And there's a number of other sort of interesting things that you can do with having this dedicated make props thing. In this case, I've actually explicitly written out make props, but you can do this with the @react component annotation as well. But this one's pretty interesting because you can have control over the type of your props. So in this case, basically we have a .re file, and then we have an interface file underneath it. And all we're doing here is in the interface file, we're making the type of props itself, which in this case is like a person object, abstract. So it's now like, it now can't be created by anyone outside of this component. So if you want like a lot of control over how your props are getting crafted and exactly what needs to happen, and you don't want to be able to sort of like structurally match against anything that looks similar, you can use this and have a lot more sort of granularity of control over how you're actually constructing props, which is pretty cool. It's also interesting that BuckleScript has like a bunch of different ways to represent JavaScript objects. So you can use basically any of these to be the value of your props. Like you can use a BS deriving abstract, or you can use, in this case, like the JSON syntax for a JavaScript object. So these are some of the ways that I think that it's better now, and I want to talk a little bit about how I think it could be better in the future. So the first one that I think is super interesting is this RFC that's out right now. Definitely, again, I recommend that you take a look at this because I think it's really important for React.js as well. But basically, it's an RFC that sort of changes create element. So create element would actually get deprecated, and there would be a new function called react.jsx, and there'd actually be a second function called jsxs as well. But I won't go into that. Read the RFC. It's pretty cool. And essentially, what it boils down to is like they want the create element, or now JSX call, to be just an object creation. There's no validation, no manipulation of any values, nothing. It's just object creation. And I'm going to show you, this is the comparison of the two APIs basically. So there's a couple issues with create element that are really problematic here. The first is that we have, the most obvious is that we have this variadic children argument, and children is also a prop. So you can actually pass children in two different ways. You can pass children in as part of the props object, or you can variadically pass it in after the fact, right? And this creates a really weird dynamic of like, which one do you trust? And like, from a type perspective, like, which one actually is the real children? Like, it's kind of weird. And so this is pretty problematic. And then there's additionally ones, the other one that you can see here is that key gets lifted outside of props. So key is no longer on the props object, which is great because you can't access key on the props object anyway inside of a child component. So it never really made sense there. So now it's very explicit here. And then there's a third thing that's going to change that isn't visible in the API, which is that ref will just become a regular prop. So right now you have to do like forward ref and a bunch of like really weird stuff to use refs on function components. And once this API is complete, like that will kind of just go away. And if you pass a ref prop to a component and it looks at its ref prop, it'll be whatever you passed. There's just nothing special necessary here. And that's kind of like how it's always meant to be, but because of weird API reasons and legacy reasons in React.js, like it just couldn't work out that way. So I'm really excited for this. These are the things it changes. And I want to talk specifically then about how it helps Reason, and it's going to help Reason in a lot of really cool ways. So first off, it's going to help everyone with performance benefits. We're going to have fewer runtime checks. We're going to have fewer runtime manipulations. The function is going to be much simpler. It's going to be easy to JIT, hopefully, fingers crossed. And it's going to be great for everyone. It's also for us going to be much simpler code. So a lot of the special casing that we do for refs and children and keys no longer need to be special cased. The way that we handle children in the React PAPX is going to change. But that doesn't mean that it's going to be much better for people who are using React today. But one thing that's super interesting is that for people who are using React today, you can see like really concrete benefits is that when you create a component, we kind of like magically add a key and a ref to your props. And that won't happen anymore. So you'll have like very explicit control over what kind of props you accept, and it'll be easier to manually create like make props functions, which is pretty nice. It also means that we won't have to rely on this special case like React semantics of like, oh, do you prefer the children inside of your props object or the variadic children coming afterwards? And then finally, I think it opens up some really interesting capabilities here for key warnings. So key warnings are like probably one of the most common runtime warnings that you can run into with React, where you're creating a dynamic list of elements and you update them. And unless React understands like what the contents of that thing is, identified by a key, it can't do a really, it can't do the best, most performant job updating that dynamic list. So adding keys to basically any dynamic list of elements allows you to keep React's work to a minimum and be very performant, right? That's like why keys exist. Here's an example of the warning you could get. So with JSX, we now have this sort of interesting API where you're passing in the component and the props, and then you can optionally pass in a key if you want to. Alternatively, with a slight change of API, we could instead have two different functions that you could call. One that requires a string and returns an element that we know has been keyed, and another that doesn't require a string, in fact does not take a string, cannot take a string, and returns an element that we know for a fact is unkeyed, right? And with this information, we can actually now track that at the type level statically during compilation. And we can add sort of this gatekeeper. So in this case, it's React.array that's the gatekeeper that says, I'm going to take an array of only elements that have been keyed, and I myself am going to return an element that's unkeyed. And what you end up with is writing a sort of map over a list of friends and returning a div and getting a compile time error that says that that div needed to be keyed. That the array should have been an array of keyed elements. And so you now can at the type level sort of see all of your key warnings instead of having to run your app and see them at runtime. And I think that this is a pretty huge thing. I think it would be really, really great for us. Thank you. Another thing that I want to talk about that's definitely possible, but a little bit more hypothetical and something to think about is DOM elements. So right now there's explicitly two types of components in React. There's like primitive components or DOM components, I don't know what you want to call them, but in this case it's like div, and at runtime in JavaScript it's like the string div is the component div, right? And then there are components that you make, and these are functions, and you pass in the function. And in both JS and in Reason, we have special casing for these two things, right? So basically, we have to have two completely different code paths, and it causes a lot of weirdness with typing exactly how the DOM props work. So one thing we can do is sort of unify this namespace. So we have like a react.dom, and inside of that react.dom module, we put like react.dom.div, right? And we tell the compiler this is a component that takes the props for an HTML div and returns a React element, but in reality it'll just be the string div, right? And in this way, let's get an example here. Yeah. So in this way, we could basically write the same code that we have today, where we do a local open. I forgot a dot. It should be react.dom dot. And then we basically write the exact same code we would today, but instead we're actually pointing to these elements. And one thing that this allows us to do is have unique prop types for every single type of DOM element. So for example, inputs take different types of props than a div does. But right now, it's sort of defined as like the largest subset of props that any HTML element can take. So you can pass a value to a div, even though I don't think that makes sense. Maybe it does in some cases. And you can have much more granular control over what these kinds of elements get, which is pretty sweet. It also opens up like lowercase elements so that you can use them without having to collide with like string elements. So you can define a function locally. So you can just say like, oh yeah, let my component equal some component, and then you can immediately use that in the same module. You don't have to wrap it in an extra module or anything, which would be pretty cool. I think that there's also a ton of other things that we can look at longer term. I mean, the most obvious one I think is better protection for hooks, static detection for hooks. There's tons of prior art with Reverie and Brisk and a couple other libraries for how to do this. The trick is like finding the right balance between not adding like a huge runtime to React and allowing people to still ship, lightweight and usable products, but being able to give people that protection. I think that another thing is that transitions and animations are historically pretty hard to do in React, and if you have more type information about how these are operating, I think it's actually a lot easier to write a lot of these sorts of animations. So this is another space. There's also another thing that I've been talking to a couple different people at the conference so far about wanting to be able to have components that only take children of a particular type. So you only want to have you have like a UI library that's a table, and you want to only take in the cells that you've defined with that table. You don't want to just take in any table cell, right? And I think that this, in a similar way to the way that Element can track key or unkeyed state, like you might be able to do something similar there. I think that there's tons of different places where Reason can really lift up React and make it an even more powerful library to use, and I'm definitely down to chat about that with anyone. The slides that I have are already up on my GitHub, and I definitely encourage you to take a look at ReasonReact and contribute or ask questions, file issues if you have anything, and feel free to reach out to me.